In this video, we're going to take a look at the graphing rational functions investigation. I recommend strongly that you start by trying the investigation yourself first. You'll learn more that way, and then come back and finish watching to check your answers and see how I filled it out. So if you're watching right now, I would recommend pausing the video, trying the first 2 pages of the investigation on your own, and then coming back to the video to check your answers. Okay, so this section is on vertical asymptotes and x-intercepts. So it says, consider the following graphs and answer the questions below. So I have a at x equals 1 over x plus 2. I have x minus 1 over x plus 1, x minus 3. And I have x minus 1, x minus 6 divided by 2 times x minus 2. So the questions that we're being asked to consider are, what connection do you notice between the factored form of the equation and the location of the vertical asymptotes? So what I really should do first is look at the graphs and figure out where are the vertical asymptotes. So the vertical asymptotes are going to be where you have a break in the graph where the two ends are pointing in different directions. So on this graph, the vertical asymptote is at -2. On this one, there's a vertical asymptote at -1 and +3. And on this last graph, there's a vertical asymptote at +2. So if I look at this one, it had a -2. And I notice in the denominator, there's an x plus 2. That's interesting. For this one, I have one at -1 and +3. And in the denominator, I have a bracket of x minus 3. And then I have one on the numerator and the denominator, but I'm kind of noticing that this is also in the denominator and it has a 1 in it. This last one, our asymptote was at 2, and I had x minus 2. So if I were to take 2 and put it in the bracket, 2 minus 2 is 0. If I put 3 in here, 3 minus 3 is 0. If I put -1 in, -1 plus 1 is 0. And if I put -2 in, -2 plus 2 is 0. So the asymptote comes from what makes the denominator of your function equal 0. So what connection do I notice between the vertical asymptote and the factored form? I'm going to say the vertical asymptote is the value that makes the denominator 0. I probably should have specified that it was the x value that makes the denominator 0. Okay, our second question says, what connection do you notice between the factored form of the equation and the location of the x-intercepts? So if I take a look at my graphs again, my very first graph doesn't actually have any x-intercepts. It gets really close to the x-axis, but it doesn't really seem to cross. So this doesn't have any. This one here has an x-intercept at +1. And this one here has x-intercepts at 3 and 6. So we discussed x-intercepts with polynomial functions. And if you look at this, you'll notice that x minus 6, if I do +6, 6 minus 6 is 0. If I take the 3, 3 minus 3 is 0. If I take the 1, 1 minus 1 is 0. And then here, I didn't have any x-intercepts, but I also didn't have any x's in the numerator. So for the x-intercepts come from the numerator, and what makes the numerator equal 0? So I'm going to say they are the x values that make the numerator 0. So the denominator being 0, that's what gives me a vertical asymptote. The numerator being 0 is what gives me an x-intercept. And if I think about it, that kind of makes sense. So if the denominator is 0, you can't divide by 0. You get an error, or it's undefined, which is why there's an asymptote, right? So the asymptote occurs where the function is undefined, or in this case, where I am dividing by 0. The x-intercepts happen where the function y equals 0. So if I were to set each of these equations equal to 0, the denominator would multiply over and become 0, and then it would just be the numerator that we'd be focusing on. So the numerator gives me the x-intercepts, the denominator gives me my vertical asymptotes. So using that knowledge, I'm just going to refocus. There's a question. It says, state the vertical asymptotes of the function f of x equals 3x times x minus 9 over x plus 7 times 2x minus 11. So we are looking for vertical asymptotes. The vertical asymptotes happen where the denominator equals 0. So I want to know what's going to make x plus 7 times 2x minus 11 equal 0. So from here, I would just set x plus 7 equal to 0. I don't really have a lot of space for this, which would give me negative 7. And then for the other one, 2x minus 11, I would set that equal to 0. I would add 11 to both sides and then divide by 2 to get 11 over 2. So this would have vertical asymptotes at negative 7 and 11 over 2. All right, our next one says state the x-intercepts of the same function we just did. So for the x-intercepts, y is always equal to 0. That's how we find x-intercepts. And if we were to cross-multiply this equation, the x plus 7 times 2x minus 11 would go to the other side, multiply with the 0, and just become 0. So really, we just focus on the numerator and what makes that 0. So that is what makes 3x times x minus 9 equals 0. Well, I would have 3x equals 0, which means 0 divided by 3 is just 0, so x equals 0. And then what makes x minus 9 0? Would add 9 to both sides to get positive 9. So this would have x-intercepts at 9 and 0. All right, our last question on this page says, using the x-intercepts and the vertical asymptotes, determine the equation of the graph shown on the right. So there is a graph here. Just need to adjust the camera. And I want to try to use the x-intercepts and the vertical asymptotes to try to put together an equation. So if I look at my x-intercepts, I have x-intercepts at -1 and +3. So for the x-intercepts, I know that I have x equals -1 and x equals +3. If I were to move these to the other side to figure out what the bracket looked like, I would have had x plus 1 and x minus 3. So all I'm doing here is this in reverse, right? I'm taking the answer and then I'm rearranging so that I get 0 on the one side so that I can figure out what the bracket was. So in the numerator, I would have had an x plus 1 and an x minus 3. So in my function, let's just call this f of x. The numerator would be x plus 1, x minus 3. Now for the denominator, I need to look at my vertical asymptotes. So if I look at my graph again, I have a vertical asymptote at 0, and then another one at 2. So if I look at x equals 0 and x equals 2, well, the x equals 2, I can move the 2 to the other side by subtracting to get x minus 2 equals 0. So that means one of the brackets was x minus 2. This one already equals 0, So it's just an x. Now, to be honest, I don't know if it's an x or a 2x or a 5x. Like in this one here, I had an x and it had a coefficient of 3. I wouldn't really be able to tell that just from the asymptotes and the x-intercepts. So from here, in the denominator, there should be an x and an x minus 2. So this is the basic equation for that graph using just the intercepts and the asymptotes. Now, I will let you in on a little secret. There could be a number in front that we don't know about, right? Like maybe there's a little 3 there, either in the top or on the bottom or somewhere else, and we will eventually talk about how to find that, but that is not a problem for today. Today we're just talking about finding x-intercepts and vertical asymptotes. So you can join me in the next video to do the next page.